Now we'll see the operations on the graph. The operations are in degree, out degree, breadth first search, and depth first search. Before moving on to this, I'm going to show you a header file that need to be included in the program. The header file that I have written with three different functions, where we are going to create a matrix which is called adjacency matrix. This creation of the adjacency matrix may be done dynamically or via statically. Dynamically in the sense by using dynamic memory allocation, and via statically means we can enter the matrix manually like this. Here I am going to explain the three different functions which will do the same task, but these three different functions will take the input in three different ways. Here, first function create matrix with copy. It will take a static matrix like this and will convert into a dynamic form. The dynamic form is the graph representation in adjacency matrix form. While coming to the create matrix, this particular create matrix will create a dynamic two-dimensional array of number of vectors, because we need a two-dimensional array of size number of vectors into number of vertices into number of vertices. Next, create a matrix from file. Sometimes some graphs will be there with a huge number of vertices and connectivities. So that particular connectivities can be written into a text file, and the text file can be passed as a parameter to this function. Thereby, adjacency matrix will be created. Next, show matrix to display the matrix. Next is read matrix. This read matrix function, whenever you call it, it will create the dynamic matrix and initialize with the initial value that you supply. The initial value may be supplied as 0 or infinity depending upon the graph type that you are selecting or you are inputting. Once it is done, then it will ask the user to enter the connectivity edges and corresponding weights. Enter the edge connectivity, vertex, and weight. You are supposed to give the input like that. Example, to enter an edge between 1 and 3, you are supposed to decrement this 1 by 1 and 3 by 1, because all these programs what I am going to write has written by assuming that the array index will always start from 0. So I have assumed that even though it is the vertex 1, I have assumed it as vertex 0. So whenever you are entering, there is an edge between 1 to 3, you are supposed to enter it as 0 to 2 and corresponding connectivity. If it is an unweighted graph, then the connectivity will be written like this, or input will be written like this: 0, 2, and 1. Undirected weighted graph. If it is so, for example, if the weight is 10, then 0, 2, 10, like that you are supposed to give. Directed unweighted graph, then 0, 2, and 1. Directed weighted graph, then whatever the vertex is there, whatever the edge is there, it will be like this: 0, 2, and 10. And to exit from giving the inputs, you are supposed to give -1, -1, and -1 to stop this particular giving of inputs. So this particular inputs will be recorded and will be saved in the dynamically created array, that is graph array, and in that these weights are stored. Finally, this graph will be returned. These are the three functions I have written. That means one function will create the adjacency matrix dynamically, and user can enter the edge and weight information. Second function is if you are having a static array or static matrix, that can be converted into a dynamic matrix. Third one is if the graph input was typed in a text file, that can be read via our function, and a dynamic adjacency matrix will be created. So this is what the graph.h header file. So this graph.h header file need to be included in the graph operations.c file. This graph operations we are going to cover here are calculating the in degree, calculating out degree, calculating the breadth first search traversal of, and also providing the spanning tree, depth first search, breadth first search traversal and depth first search traversal. Here the example graph that I have considered is this one. This already I have discussed in the lecture. Here graph representation, adjacency matrix and adjacency list. Here adjacency matrix will be represented like this. If you convert it into the program form, then the two-dimensional array will be represented like this. And remember, whatever the representation that you make manually, you are supposed to give the name as sgraph, because the functions that I have written in the header file will be taking the sgraph as the input. Once it is done, then I have taken the help of the stack.h, q.h, which are required for traversal of the breadth first search and depth first search respectively. So this graph, this stack.h and q.h will implement the stack operations and queue operations. And here the number of vertices, I have given a macro, that is has defined NOV, number of vertices, to her 8. Define init, initialization is 0. Wait is for 1. This is especially to insert the inserting the elements or vertices into the stack or queue, and checking for next adjacent vertices and to pass through. For that we need whether the vertex is visited or not, or whether it is in the initial state or waiting state or completed state. So for this init, wait and visited, these three macros have been used. Has defined inp, this macro is to represent an infinite value. So here I have presented a long value, or I have presented a big number to represent an infinity. So declaring the static graph, the graph will be declared like this. This graph, this representation, this two-dimensional representation is the adjacency matrix of the graph that what we have discussed in the lecture. Next, in degree. In degree, by making the in degree of a vertex is calculated like this. Function for in degree calculation. Number of edges coming into the vertex is said to be in degree. This will be counted like count the connectivity along the column. So you are supposed to connect. You are supposed to calculate how many number of connectivities are there along the column of a particular vertex. Say for example, this is the 0 vertex. I want to calculate the 0 vertex in degree. Then you are supposed to count how many number of connectivities are there along the column. Then here 1 and 2. So that means 2 is the in degree of this particular thing. So like this, you have to calculate along the column. So this particular code will give you the calculation of the connectivity along the column and will return the in degree value. Then out degree, function for out degree calculation, number of edges going out from a vertex. So for this you are supposed to count the connectivity along the rows. I want to know what is the out degree of a vertex 3. So 0, 1, 2, 3. So you are supposed to calculate how many connectivities are there along the row. So here 1 and 2. So out degree is 2. Like that, this out degree will be calculated. Next one is function for breadth first search. Breadth first search, you are aware of that. In the lecture we discussed it, that for BFS we require a queue. So for this, first you are supposed to set the status as 1 for each node in the G. Enqueue the starting node and set its status as 2. Here status as 2 means here what I'm doing is I'm placing the status as wait state. Here they have mentioned as 2, no problem. Here let will say status as 0 and status as 1 and status as 2. That means initial state, waiting state, and visited state. Like this, three states I'm going to mention. So whenever we have considered the vertex and kept in queue, you are supposed to take the all its adjacent vertices and push it into the queue. While queue is not empty, dequeue a node n, process it in the sense you have to take the adjacent nodes and again place it in the queue. Like that, you have to keep on repeating till the queue is empty. So here BFS traversal. So the breadth first traversal, you are supposed to pass a adjacency matrix. This adjacency matrix is the graph that we are going to input. And what is the starting vertex? Initialize the visited array. So the visited array will be initialized to init. That means no vertex is visited so far. Next, initialize the vertex visited of started vertex as visited. So visited of starting vertex is equal to a wait. That means we have visited, but it is supposed to be processed. Then insert of s vertex. So this is the insert operation of q. This is available in the graph in the q.h that I have included in the file. Printf breadth first traversal while q is not empty. Then remove the element from the queue. So vertex of that particular removed element is equal to visited. Then visited of that particular vertex, removed vertex is visited. Then printf the vertex that whatever we have removed from the queue. Then for I is equal to 0, I less than number of vertices. If the vertex is not equal to I, that means it is not visited. Then that means if it is not referring to the same vertex, then check for the adjacency matrix of I vertex is greater than 0 or not. And if it is not visited so far, then insert it and repeat the same operation till queue becomes empty. As the while loop is repeating, whatever the vertex will be removed from the queue will be printed onto the screen. Thereby, it will follow a breadth first traversal. While coming to the depth first traversal, here we are going to use the same kind of operation. Instead of queue, we are going to use stack. So depth first traversal, initialization and visiting of the starting vertex, push the starting vertex into the stack. While stack is not equal to empty, then the same operation need to be performed by pushing the popped element into the pushing the minimum element or non-visited element or non-visited vertex into the stack. This operation we are supposed to perform. Now I am going to consider this graph. For this, whatever the adjacency matrix I have written, now what I am doing is I am writing in a graph underscore input .txt file. Now in the main method, I am using the function create matrix from file fopen of graph underscore input in read mode. So I have opened this file in read mode and I have passed the number of vertices, that is NOV. Then this particular function will return the dynamic matrix that is created by reading the input from this file, and that is the graph. Then show matrix of graph comma number of vertices, then it will print the graph. Then this code is to print the in degree of each and every node, and this code is to print the out degree of each and every node, and this BFS is for the traversing of the graph in the breadth first search manner, and DFS is for traversing the graph in the depth first search manner. That will see the output. The output is the matrix that what we have supplied. Then in degree of each and every vertex is calculated. Out degree of each vertex is calculated. The breadth first traversal of the graph is 0, 1, 2, 3, 4, 5, 6, 7, and DFS traversal is 0, 2, 6, 7, 4, 3, 5, 1. This is what the in degree and out degree calculation and BFS and DFS traversal.